Now let's apply the formulas that we wrote for torque to a problem. We will call it problem 1. For this problem 1, we will have again a rod. It doesn't mean that all problems with torque are about a rod. And this rod is pivoted about center of mass, right here. It is pivoted about the center of mass. This rod has mass m and length r, capital R. There is force of gravity applied to the center of mass acting on this rod, mg. There is normal force with which this pushes on the rod. And in addition to that, there are 2 given forces applied to this rod. One is on the left. It is vertically down and has magnitude, given magnitude of F1. It's given. And another one, I don't put vector sign here because I just showed the direction. So this arrow refers to this vector. And then there is another force. And this force is F2. It is applied to this end. So this is R over 2. This is R over 2. And both forces, F1 and F2, are given. What I want to find torque, total torque created by all of these forces about the pivot point, about point O, pivot point. So what is torque created by gravity? Torque created by gravity will be 0. Why? I didn't even write the equation that we will be using. I forgot. Tau is R cross F. F is force of gravity. R is from the pivot to the point where the force is applied. So torque created by gravity is 0. What about torque created by normal force? Normal force is up. This is pivot. From the pivot to the point, R is again 0. So torque created by gravity is equal to torque created by normal force about this pivot point. And it is 0 because R is 0. They are applied to the pivot point. Now we will find torque created by F1 and torque created by F2. What will be torque created by F1? Tau F1. This is F1. R and magnitude is given. R is from the pivot to the point where the force is applied. This is R1. And direction is shown. It is to the left. I have F1 and R1 perpendicular to each other. Great. So it is torque is F1. Magnitude of R1 is capital R over 2. Let me do this. F1 and then R over 2. This is magnitude of torque. R times F, and they're perpendicular to each other. All I need to find the direction. And to find the direction, we always bring these 2 vectors. We start them from the same point. This is F1. R1 is to the left. Now you use your right hand, and I use my left hand because you see my mirrored image. Before I start putting my hand here, there. Let's narrow down our choices. So what are our choices? Either into the board or out of the board, because torque is cross product. It is perpendicular to the plane of original 2 vectors. You take your right hand, you put your fingers along R1, you bend them towards F1. From R1 to F1, where does my thumb go? In or out? From R1 to F1, it is coming out of the page. So the direction of torque created by F1 about this point is out. How do I show this? This will be out of the page. And if I introduce a coordinate system, which coordinate system would you like to use? Not important. So I will use probably the standard coordinate system. For this problem, it's not important. Sometimes it really matters. So x, y, and z follow right-hand rule. This is x, this is y, and z is out. And if I use unit vectors I, j, and k, again, as in the previous video, then I can write it in terms of unit vector k, f1, r over 2, unit vector k, which is in the direction of positive z. We found tau f1. What is tau f2? Torque created by force F2 is equal to, force is F2, R is from the pivot to the point where the force is applied, from the pivot to the point, this is R2. So I have F2 times R2, magnitude of R2 is capital R over 2, and these two, F2 and R2, are perpendicular to each other. I found the magnitude of torque. Now I need to find the direction. And to find the direction, as always, we start these two vectors from the same point. F2 is down, R2 is to the right. Use your right hand now. Give me 1 second. So my choices are in or out. You probably already guessed the answer, but I'll still do that. So my fingers are along R2. I bend them towards F. I cannot switch the order. It is from R to F. And my thumb shows direction in. So the direction of this torque is into the page. Into the page. This is direction of torque. And I will put it here. It is into the page. Or if I want to write it in terms of unit vectors, as I did here, it will be F2, R over 2, and minus K. It is into the board along negative direction of Z. So now I need to find torque total, which means I need to find the vector sum of all torques exerted on this rod, which will be tau created by F1 plus tau as a vector created by F2 plus tau created by gravity and plus torque created by the normal force. Well, this one is 0, this one is 0. Torque created by F1 is F1 R over 2 along K. Torque created by F2 is F2 R over 2 along minus K. I can factor out minus here, and I will also factor out R over 2. So I have F1 minus F2, F1 minus F2, R over 2, and it is K. Now, let's look at this answer again. So, for example, I have F1 5 newtons, and I have F2 3 newtons. 5 minus 3 is 2. I plug in R, and I get torque in positive Z direction. Now, what happens if this is 2, for example, and this is 5? 2 minus 5 is a negative number. It's minus 3. So I'll have here minus 3 times R over 2K, which means that I will have torque in negative direction. So we derive this torque. We calculated the torque created by these two forces, and your solution will take care. Finally, at the very end, you will plug in the numbers. What is given? What are the magnitudes of F1 and F2? And you will figure out, is it really in positive direction, which means positive z direction with my choice of coordinate system, which means that F1 is greater than F2. Or if F2 is greater than F1, it will be in negative z direction with my choice of coordinate system.